All right, welcome back. Thanks for clicking like, subscribers. All right, so today we're going to learn the last two methods to prove triangles similar. Last time we learned about angle, angle. And we're going to learn about, are you guys laughing at me? Side, 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 and side angle, side. I must say it's much better recording myself when I have a class to make fun of me than when I have to just listen to myself or like teach them White. I was watching it. I was like, this is pretty boring. So today's going to be much more interesting, especially with my Kanye hat. All cool. I look all fly today. All right. So the second method to proving triangles similar is side, side, side. Now, we have a side, side, side for proving triangles congruent, right? And that's when all the corresponding sets of sides were actually the same length, congruent, okay? These are going to be proportional. So what does that mean? All right, so let's say I made this length, those lengths 2, 3, and 4. Right, keep this 3 greater than 4. All right, so if I make that 2, I want to make this 4. What would the length of this side then have to be if I want to keep the same ratio?
6.
Okay, so 3 times 2 is 6, and then 4 times 2, 8. That's all side, side, side means. This ratio is the same as this ratio is the same as that ratio. If the corresponding side lengths of two triangles are proportional. Then triangles are similar. You see that? I don't know quite how to do that. Like I like to, they like move back and they put their arms forward at the same time.
Keem's got some good moves that he needs to show you tomorrow.
Oh. All right, so okay, so let's try to figure out which two of these triangles are similar. Okay, so we start with A, B, C, and D, E, F. Okay, so the two shortest sides are, okay, 8, 9, and 12. So the shortest side here, this triangle is 8, and 4, 6, and 8. The shortest side here is 4, right? So those correspond to each other. So we're going to, AB is the DE. When you simplify that, you get 2 to 1, not 2. It's a ratio. Okay, let's look at the longest sides now of those two triangles. We've got a 12 and an 8. Uh-oh. When I simplify 12 to 8, I'm not going to get 2 to 1, am I? What am I going to get? I guess they're calculators, right? Math frac?
3 over 2.
Okay, thank you. And then the last, I already used blue. Black. Okay. 9 to 6. Ooh, that's going to be 3 over 2 as well. But either way, all the ratios are not equal. So those two triangles are good. Not similar. Well, what about triangle GHJ? Let's see if that one is similar to ABC. All right, so shortest sides, 8 and 16. Okay, so this triangle has been flipped. Okay, so 8 to 16, and that's 1 to 2 when you simplify, right?
Yeah.
Okay, longest sides, 12 and 24. Ooh, 1 to 2. Let's see what the last set. Oh, I used black. I used blue. 9 and 18. Oh my gosh, this is so exciting. Look, the ratio of each of the sets of corresponding sides, same ratio.
Whoa.
So all the ratios are equal. So triangle ABC is similar to triangle GHJ.
Actually, it would have to be GHG or JHG because you do ABC.
But they took this triangle, and see how this is the shorter side here for ABC,
okay.
and this is the shorter side here. They took it and flipped it. It's trying to show that with the different colors, because see how the blue ones are on the inside here and the black ones on the outside? They flipped it like that. All right, glad you pointed that out. Done? Ready to move on? Mm-hmm. What? All right. So now we have to find the value of x that makes triangle ABC and DEF similar. Okay, so we've got 3 sets of corresponding sides. Right? 4 corresponds to 10. This 10 corresponds to that 2x plus 3. And this x plus 3 corresponds to that 20. When we write a proportion, we only need 2 sets. It'd be nice if we just had 1 unknown and 3 numbers. Okay, let's see. How about we use that 4 and 10 for one side of the proportion? There are different ways to write proportions, so I just chose, I like those numbers. I put the 4 over the 10. You could have put the 10 over the 4. That's just what I chose. So now I have to choose, do we want, if we put the 4 over the 10, we either have to put on the other side the 10 over the 2x plus 3, or the x minus 3 over the 20. What do you want to do? I think the x minus 3 might be easier than the x plus 3. Okay, so 4 over the 10, then the x minus 3 has to go over the 20. I'm recording myself. Yes? Do you want food or something?
Oh.
I'm recording myself.
Hi, I'm
Oh,
Matt.
hi.
Do you need something?
Where's Brian? Brian's in there.
Thanks for stopping in while I'm teaching.
What's up with the hat?
Do you need something?
I'm playing with
Oh,
ball.
that food?
She already asked. Do you know where it is?
Yeah.
So I'm literally recording myself.
Alright,
You're going to be on my video.
Let's.
Yes, all the subscribers will know that you
Yeah, that's
came
right.
by begging for
Subscribers. Say
food.
hi to Matt. Hey, Matt.
Hi, I'm Matt. We're nice.
Okay, can you guys do this?
Kamani, why are you in this class?
He's
Someone
taking
feel por favor.
geometry.
Okay, so we cross multiply. This is just like your homework from last night. Distribute. Have you done this? Divide both sides by 10. You find something? Excellent.
Yep.
Thanks for stopping by.
Yep.
Slack.
Kids these days. I'm getting 11. Can someone check my math? That's great. Okay. So then we read the question again to make sure we've answered the question. It's asking for the value of x. We don't even have to plug anything in. No substitution. Boom. That's right. Okay. Am I going too fast? Are we still writing this down? Good? All right, next method, next and last method. First method just involves the angles. Second method involves just the sides. Third method involves angles and sides, just a little bit more complicated. Not too much though. Okay. So what this says is, I'm just going to pick some numbers again. I like 2 and 4. And then what do you think this length looks like? Maybe should it be 3? Okay. So if this is 2 to 4, this has to be 3 to 6. Okay. So those two sides are proportional. So we have that side is to that side as this side is to this side. Now, side angle side says is when you have these two sides, they come together to form what's called the included angle What kind of angle is it called? Included. That's just the word. It's included. It's inside those two sides. And that included angle is congruent. This is enough information to prove these two triangles congruent. Sorry, similar. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of these sides, including these angles, are
You didn't have
the sides are
that, so you
proportional,
didn't have it. There was nothing on your desk.
then the two triangles are similar. So sometimes it gets kind of tricky because they give you the wrong angle. They'll give you, eyes up here, eyes up here. They give you the two sides, okay, and then they might give you this angle is congruent to this angle. That's not the included angle. That's not in between the two sides. The two sides, think of which angle those two sides are creating. That's the angle we need. So one example, and then we're done. This looks really complicated. It's actually not. It's not my favorite example of side angle side, but you know. You're drawing a design for a bird feeder. Can you construct the top so it is similar to the bottom using the angle measure and the length shown? Okay. Well, the first thing we are going to notice is that angle B and angle E are both 87 degrees. Okay. The measure of angle B and the measure of angle E equal 87 degrees. So those two angles are going to be congruent. Okay. So we have our angle. Now we need to see if that set of corresponding sides is going to be the same ratio when I simplify this side. So AB to DE. Hey, wait a second. 32 to 20. 32 to 20. They're the same numbers. So when you simplify them, they're going to be the same ratios. Do they use EF? So that's going to be BC. 30. 32 to 20. Now, when you simplify that ratio, what do you get? Take out the calculator, math frac.
8/5.
Thank you. All right, page 5. So the lengths of the sides that include angle B and angle E are, the two triangles will be similar, but the lengths of the sides are that's right. So by the side angle side similarity theorem, triangle ABC is similar to triangle DEF. I really want you to write side angle side similarity theorem because we have a side angle side congruence postulate too. So just to be clear.